This is Dr. VNSR Venkateswara Rao, working as Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad 543. So today I would like to give the topic of related to the lubricants, nothing but properties of the lubricants. So first of all, we see what are the contents involved in today's topic. So first one is the flash and fire point, and second one is the cloud and pour point. After that, we discuss about the viscosity. Finally, finish with the oiliness of the properties of the lubricants. So let us start with the flash and fire point. So flash and fire point. First of all, we see the definition of the flash point, then fire point. So flash point is nothing but the volatile material is the lowest temperature at which vapors of the material will ignite given an ignition source. That means the flash point of a volatile material. Volatile means easily evaporated, like chlorines present in hydrochloric acid. That is nothing but a volatile material. And ammonia is also best example for a volatile material. That means they get easily evaporated in the presence of the environment. So for these substances having the lowest temperature at which the vapors of the material will ignite. Ignite means burning takes place, given an ignition source. So this is about the definition of a flash point. Once again I repeat, the flash point of a volatile material. The flash point of a volatile material is the lowest temperature at which vapors of the material will ignite given an ignition source. Okay. After that, we see the fire point. That means the fire point of a fuel is the lowest temperature. The fire point of the fuel is the lowest temperature at which the vapor of that fuel will continue to burn. At least 5 seconds. At least 5 seconds after ignition by an open flame. So this is about the fire point. That means the fire point of a fuel. Fuel is nothing but a hydrocarbon. That means either petrol, diesel, kerosene, or may be taken as any hydrocarbons materials having the lowest temperature at which the vapor of that fuel will continue to burn for at least 5 seconds after ignition by an open flame. So this is about the fire point. Once again repeat, the fire point of a fuel is the lowest temperature at which the vapor of that fuel will continue to burn at least 5 seconds after ignition by an open flame. Okay, so this is about the apparatus involvement of the flash and fire point. So first of all, we see burner for the test flame, and second one is the pilot burner, and third one is the thermometer, and fourth one is the stirrer, and fifth one is the shutter control, and sixth one is nothing but a oil level meter, and stirrer blade, and oil cup, and air bath, and this is nothing but the opening part of the beaker. So it contains totally 10 components present in the apparatus of a flash and fire point. Now let us see how to determination of the flash and fire point. So first of all, the description of the determination of flash and fire points. The apparatus consists of a brass cup and a cover fitted with the shutter mechanism. Without shutter mechanism, open cup. That means if it is covered, that is nothing but a shutter mechanism. So without shutter, so that is the phenomena, nothing but a open cup mechanism. So test film arrangement and hand stirrer. So especially in the closed cup and thermometer socket, etc. Heat with energy regulator. A thermometer socket made up of the metal, nothing but copper. So this is about the description of the determination of flash and fire points. So after that, we see how to determine the flash and fire point for the required procedure. So first of all, clean the oil cup thoroughly and fill the oil cup with the sample oil to be tested up to the mark. So insert the thermometer into the oil cup through a provision which measures the rise of oil temperature, and using the energy regulator control the power supply given to the heater and rate of the heating. That means the oil is heated slowly. When temperature of the oil rises, it is checked for the flash point for every 1 degree rise in temperature. Okay, so this is the first step of the procedure. So after determining of the flash point, the heating shall be further continuation takes place. That means the temperature at which the time of flame of application which causes the burning for a period at least 5 seconds shall be recorded at the fire point. So that means after the determination of the flash point, the heating shall be further continuous. That means what happens? The temperature at which the flame application which causes burning for a period at least 5 seconds. Such point is nothing but a fire point. Okay, so this is the determination of flash and fire point. Now repeat the experiment nearby 2 to 3 times. 2 or 3 times with the fresh sample of the same oil. So by taking the average value of these 2 to 3 readings to get a final value of flash and fire points. Okay, so this is about the determination of flash and fire point, including apparatus. So after that we see the second property of the lubricants, nothing but cloud and pour point. Cloud and pour points. So first of all we see the definition of cloud point, the temperature at which the impurities being to separate from the solution and lubricating oil becomes cloudy or hazy in appearance is called cloud point. So that means the cloudy means the solvent should not be clear. The solvent should not be clear. Why the solvent should not be clear? Because of the impurities present in that lubricating oil. Presence of the impurities, the lubricating oil should not be clear. Such position is nothing but a cloudy or hazy position. Cloudy or hazy position. Okay, that means the temperature at which the impurities being to separate, from the solution and lubricating oil becomes the cloudy or hazy position. That appearance is called as a cloud point. And pour point means the temperature at which oil ceases to flow. And that pour is called as a pour point. That means in this point the oil ready to involve the flow process. That means the oil ready to involvement of the flowing process. That is pouring position. That's why this is called as a pour point. That means the temperature at which oil ready to flow or ceases to flow, that pour position is nothing but a pour point. So this is about the apparatus involved in the cloud and pour point. First of all, it contains thermometers and cork and jacket. After that, we see test jar, then gasket, then cooling bath, then disc, and maintained temperature conditions are 40 to 50 ID and 30 to 335 ID's position. So these are the total 7 components present in the cloud and pour points apparatus. So now we see how to determine the cloud and pour point by using these apparatus. First of all, we discuss about the determination of the cloud point, then move to determination of the pour point. So bring the sample to a temperature of at least 15 degrees centigrade above the approximate cloud point and pour point into the jar to a height of 51 to 57 millimeter height, 57 to 57 millimeters height position, and close the jar with the cork so that the thermometer bulb rests on the center of the bottom of the jar. Now fit the gasket on the jar 25 millimeters from the bottom and insert the jar into the gasket. Now, support the jacket and jar in a vertical position in a bath so that not more than 25 millimeters projects from the cooling medium. That means at each thermometer reading of 1 degree centigrade, remove the jar from the jacket quickly but without disturbing the oil. Inspect of the material for cloud and replace the jar. This complete operation shall not take more than 3 seconds. That means within rapid position, the entire position will be takes place. That means if the sample does not show a cloud when it has been cooled up to 10 degree centigrade. Now place the jar and jacket in another bath maintained at a temperature of the 15 degree centigrade to minus 18 degree centigrade. If the sample does not show a cloud when it has been cooled up to minus 7 degree centigrade. Now place the jar and jacket in another bath maintained at a temperature of the 32 degree centigrade to minus 35 degree centigrade. But this condition is possible in the case of the if the oil should not show any clouding position. Now, when a inspection of the sample first reveals a distant cloudiness or haze at the bottom of the jar, record the reading of the thermometer as the cloud point after correcting the thermometer errors necessary. So, this is about the cloud point determination. After that, we see the determination of the pour point. So the sample has cooled enough to allow the formation of the crystals. Formation of the crystals. Maintain the bath temperature minus 1 degree centigrade to 2 degree centigrade. Okay, now support the jacket or jar in a vertical position in the bath so that not more than 25 millimeters projects from the cooling medium. So beginning at a temperature 12 degrees centigrade above the expected pour point at the each thermometer reading, which is a multiple of the 3 degree centigrade. Now remove the jar from the jacket. So carefully until just enough to see whether the oil will move and replace it. This complete operation shall not take more than 3 seconds. And as soon as the sample ceases to flow, when the jar is titled, hold the jar in horizontal position for exactly 5 seconds. So if the sample shows any movement, replace the jar in the jacket and cool down the sample for another 3 degree centigrade. Okay, now if the oil shows no movement during the 5 seconds, record the reading of the thermometer. Add 3 degrees centigrade to the temperature recorded above and corrected for the thermometer errors if necessary. So that means, and finally note down the result of the pour point. So this is the determination of the pour point of the lubricants. Now, after that, we see the viscosity of the lubricants. This is one of the important property. Viscosity is nothing but the dragging force between the two layers. The dragging force between the two layers. That means viscosity is the property of a fluid that determines the resistance to flow, and it is an indicator of flow ability of lubricating oil. That means the lower the viscosity, greater the flow ability. The lower the viscosity, greater the flow ability. That means viscosity is inversely proportional to flow ability. Viscosity is inversely proportional to flow ability. Viscosity is inversely proportional to flow ability. Okay, and if the temperature increases, viscosity of lubricating oil decreases, and it is also inversely proportional to temperature. Viscosity is inversely proportional to temperature. And finally, when pressure increases, viscosity of the lubricating oil also increases. So viscosity is directly proportional to pressure. So this is about the viscosity of the lubricating oil with respect to different conditions. So first one is viscosity is inversely proportional to flowability, and viscosity is inversely proportional to temperature, and viscosity is directly proportional to pressure. So viscosity is nothing but a resistance to flow. Okay, that means the dragging force between the two layers. And finally, we discuss with the oiliness of the lubricants. So the term oiliness is defined as that property of the lubricants by virtue of which one fluid gives the lower coefficients of the friction than the another fluid of the same viscosity. That means the term oiliness is defined as that property of the lubricants. It gives the lower coefficients of the friction. That means the coefficient of the friction will be less compared to the another fluid having the same viscosity. So this is about the oiliness of the lubricants. So finally, we discuss about the totally four properties. First one is flash and fire point, second one is cloud and pour point, and third one is viscosity, and fourth one is the oiliness of the lubricants. So these are the very important properties of the lubricants used in various applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.